Today we are talking about the topic 7.3, which is the frustrum. Okay, so actually we are building the knowledge from the something that we learned before, for example, for pyramid and then for cone. So this time, if we're talking about something like a frustrum, no matter for of a pyramid or of the cone, both of them actually from the logic is that we got a large, for example, is a pyramid, and then we removing the smaller part out, and then the remaining, this is the figure that we call it frustrum. Okay, so actually in this kind of logic, how to calculate the volume of frustrum is also something like the whole figures minus the smaller part that we remove, and then this is the volume of the frustrum. Okay, and then no matter this is a pyramid of or a cone, we just need to do the same step. Is that we calculating the whole clone minus the smaller clone that which is removed it, then we calculating the remaining part. Okay, so actually the logic is just something like this, but we have to notice that if we want to calculate the frustrum, this is must be the upper face and the lower face, there must be in a parallel. Okay, if the figure is something like this part, the upper face is not parallel to the base, then this is actually not a frustrum. We cannot calculate something like this. Okay, so let's see something about the examples of how to calculating the frustrum. Okay, now we get a frustrum on the right hand side, and then we can see the upper part, actually the bigger face. You can see this is a square base with the sine of 10 cm. Okay, and then the height of this pyramid is totally 15 cm, right? 15 cm 9 plus 6. And then for the smaller part of this pyramid, also with a square base, right? But with a sine 4, and then the height now is a 6. So first, we calculating this. We find the volume of the smaller parts of the pyramid, V, E, F, G, H. So we remember the volume of the pyramid, just we learned it before. 1/3 times base area. What is the base area? The square is the 4 square with the base. Times height now is 6. So you will have the volume of 32 cm cube is the answer. And second, we're calculating the large part. So the bigger pyramid is 1/3 times base area, which is the 10 square, times the height. The total height, you can see this is 9 plus 6. So this is totally we have is 15. So we have the answer should be 500 cm cube. So therefore, the frustrum we just need to calculating by the bigger part minus the smaller part. Then we have 500 minus 32. We will have the answer for 468. Okay, then you can now try to do the quick practice 7.12. Also do the same thing. You find the larger part of the pyramid minus a smaller part, and then we can see both of them are in the square base. The larger with a side 7.5, smaller with a side 5 cm, and then the total height is 9. The smaller part with the height 6 cm. Then you will have the bigger part minus the smaller part. Then it's okay. Then we do another kind of example. You can see this is actually just consists of 2 examples, but actually this part we calculating the frustrum is not easy. It's something difficult because when you see the example 7.13, then you will find out that we will often use techniques which is called the similar triangle. Why we need to do something like this? Okay, you can see for this we also calculating a frustum which is of a clone now in this example, but we have some difficulties because the we need to find out, just like the logic, we need to find out the whole volume, which is the 1 over 3 times the base areas times height. And actually in this case, because this is a clone, pi r square is the base and then times height. Okay, the smaller part also we need to have this kind of formula. Therefore actually we need at least 4 data. Which 4 data is the bigger part with radius we now have. We got 9 here. The bigger part we need a height. We don't have one because we don't know the height of VP. And then we have a smaller radius we got because this is 6, the number of 6. And then we need to find out the smaller part of the height. We don't know yet. We still don't know. So we can see we don't have enough data in this case. We need to find out the h. And actually, how can we find out the h? We need to use a similar triangle. Because in this case, you can see, okay, I erase something like this. Okay, you can see this figure. Okay, for this VPB, and then the triangle VQA, we will show that this is a right angle, the similar triangle, because you can see this is the common angle for angle V. This is actually common angle. And then for VPB, VQA, we have 90 degree. So actually we got the similar triangle with AA. So how can we use this similar triangle to help us to find the height actually? Okay, by calculating the similar triangle, we have to using the ratio, because we know that this is a similar triangle. Therefore, we let VP be x in this case. You can see VP with the length with x. Okay, for the similar triangle, the x, this length, compared to the VQ, actually is x plus 8. This kind of length will be equals to the ratio to 6 to 9. So 6 to 9. Okay, that's why we need to using a similar triangle, because we want to find out the equation like this, the relationship like this. Okay, therefore we have this kind of formula, and then we multiply it to another side. So 9x equals to 6x plus 48, and then we make the 6x to another side, we get 3x equals to 48, and the x is equals to 16. Okay, after this part, we find out the length of VP, 16. And so, we can find out everything we want in these two kind of equation, no matter for whole part or for the smaller part. Therefore, if we want to find out the volume part B, right, clone VBC, the clone VBC is a smaller clone, 1 over 3 times pi r square. R is 6 for the smaller part, square times 16. So we have final answer for 192 pi cm cube for part B. Okay, finally, we need to find out the volumes of frustum. We need to find out the whole part, and then we just need to minus the smaller part, then we have the volume of frustum. So we have to calculating the volume of bigger clone. So 1 over 3 again times pi r square. Now the bigger r is 9 times height. What is the height? Which is the 16 plus the 8. So total we have 24. So we have the volume of 648 pi. So the first one again is the bigger part minus the smaller part. So we need to find out something like this. What is the most important part in this equation is that we need to using the similar triangle to find out the height of the figures. Actually, this is the most important part. So let's try with this technique, using this technique to finish the quick practice 7.13. And then actually this is the finish of 7C. Okay, you can try out the consolidation corner, find if there are any problems or you don't know. And then yes, finish the E class. Then that's all for today.